energy. These slides include some important definitions of energy. Energy is the ability to do work or transfer heat. Work is energy used to make objects with mass move. We will define it a little more explicitly later. Heat is energy used to raise the temperature of a substance. Energy can be divided into three broad categories. First is potential energy, which is energy an object has because of the position of the object in relation to other objects. This may include the positions of atoms within a molecule and the positions of molecules relative to each other. The second type is kinetic energy, which is the energy an object has due to its motion. The kinetic energy is determined by the formula you see here on the slide. The third type is called radiant energy, which is energy that is being transferred as light. The official SI unit of energy is the joule, the units of which are kilogram meter squared per second squared. 1 joule is the energy an object of mass 1 kilogram has when moving at a speed of 1 meter per second. An older, now no longer official unit of energy is the calorie. The calorie was defined as the energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. 1 calorie equals 4.184 joules. The universe is divided into two parts so that we can talk better about the changes in energy that occur. The system is the part of the universe that we are interested in. It includes the molecules and other stuff we are looking at. The surroundings are the rest of the universe. A careful choice of exactly what we want as the system and what we want as the surroundings can make a problem much easier to deal with. For example, if we have a chemical reaction occurring that produces a gas as a product, whether we include the gas as part of the system can make a big difference in how we deal with the energy change. As mentioned earlier, work is energy used to make an object move. Specifically, the work is the energy used to move an object through a certain distance. The work, symbol W, done on an object is the force applied to the object times the distance through which it is applied. If the object does not move, then no work is being done. When the force is related to the pressure, force per unit area, of a gas, it is called PV work. This is the most common type we will encounter. There are other types of work, such as electrical work, that may need to be taken into account. Heat, symbol Q, is energy being transferred by the collision of molecules that transfer kinetic energy from one molecule to another. Since heat is related to the kinetic energy of the molecules, it can also be defined as molecular kinetic energy. The heat is always transferred from a warmer object to a colder object. In order for heat to be transferred, the objects must be in contact with each other. When energy is transferred, one form of energy can be converted into another. In this particular example, the ball of clay starts with a certain amount of potential energy because it is a certain distance away from the surface of the earth. As the ball falls, it accelerates, increasing its kinetic energy. The ball moves closer to the surface of the earth, decreasing the potential energy. The loss in potential energy is the same as the increase in kinetic energy. When the ball hits the ground, it loses its kinetic energy. Some of the energy goes into the ball to change its shape, and some may be lost as heat to the ball and the ground, or sound, or some other form of energy. The first law of thermodynamics. The first law of thermodynamics is just the law of conservation of energy, restated in terms of the system and surroundings. That is, when a system gains energy, the surroundings lose that amount of energy, and when the system loses energy, the surroundings gain that amount of energy. There will be 4 principal energy functions that you will need to know the symbols and definitions for. One of the energy functions is the internal energy, which has the symbol capital E. Internal energy is the sum of all the kinetic and potential energies of all the components of the system. By the way, the other 3 energy functions are called enthalpy, the symbol is H, entropy, symbol S, and free energy, symbol G. It is impossible for us to know the internal energy of any system exactly, in part because the internal energy includes the energies of the electrons in the molecules. And in one form of the Pauli exclusion principle, it says that we cannot know the energy exactly at any particular time. However, we can easily measure the change in internal energy. Mathematically, the change is delta E equals E final minus E initial. The delta functions are always defined as final minus initial. If E final is greater than E initial, then the energy of the system has increased and delta E is greater than 0. This means that the system has absorbed energy. On the other hand, if E final is less than E initial, then the energy of the system has decreased and delta E is less than 0. This means that the system has released energy. The energy that is exchanged with the surroundings is either work or heat, and delta E is equal to Q, the heat, plus W, the work. The signs of Q and W are critical in doing calculations involving E. Here is a table which shows the signs of Q, heat, W, work, and delta E, internal energy, and what they mean. Specifically, if Q is greater than 0, that is, positive, heat is being added to the system, and if Q is less than 0, negative, heat is being lost from the system. If W is greater than 0, positive, then work is being done on the system. If W is less than 0, negative, work is being done by the system. Similarly, a positive value for delta E means energy has been added to the system, and a negative value means that the system is losing energy. 2 more important terms to define are endothermic, when heat is absorbed by the system, and exothermic, when heat is released by the system. Note that endothermic and exothermic have nothing to do with work, only heat.